In this video, we're going to learn about something called graph transformations. The idea is that we know how to graph basic functions like f of x equal to x squared. We saw those on the video on the library of functions. But then what happens if we don't want to graph x squared, but we want to graph 3 times x minus 2 squared? Right? It's a more complicated version, but it's still kind of an x squared graph. And so what we're going to do is we're going to see in this video how we can relate the graph of something like this to the basic x squared graph. And then once you know your library of functions and transformations, you can use those to graph a whole bunch more other examples of things you will come across. Now the first type of transformation is something called a shift here. And you can have horizontal or vertical shifts. The difference is if you take your function formula and you add or subtract a number outside of the formula, that would be a vertical shift, either up or down, depending on whether h is positive or negative. On the other hand, if you have your plus h inside the formula for your function, that's going to be a shift left or right, again, depending on whether h is positive or negative. I will say there is one little thing here that's easy to mess up, is that when you're doing up and down shifts, positive shifts the graph up, and negative shifts the graph down, just like you would expect it to do. However, when you are doing the left-right shifts, it's a little bit different in that if you have a positive number, that's going to be a shift left, whereas a negative is a shift right. So it's a little bit opposite of what you'd expect it to be here. It's definitely one thing to keep in mind when you're doing these problems. So for this first one, instead of giving you a standard formula, I wanted to show how it works generically here. So here's some random graph of some random function. And I want to do f of x minus 1. What that means is you want to take that exact shape, that exact graph, and you want to move everything down by 1. So in the original picture, it was over here at 2, 1. Now it's going to go down to 2, negative 1. And then it's going to look something like this. Now, I didn't give you exact y values for these points here, but whatever they would be, you just move them down by 1 unit. However, this is the idea of what it's supposed to look like. So you just move everything down. On the other hand, f of x plus 2, that's adding 2 inside the formula here. That means it's going to be a left shift, because again, positive means left in this case. So we're going to move it left 2 units. So originally it was at 2, 0. Move it left 2. It's going to be at 0, 0. And the graph's going to look something like that. Okay, so this is the most common thing you're going to deal with is shifting left, right, up, and down. And you definitely want to make sure you are able to handle those. The next one is also pretty common. It is reflections here. There are going to be two types of reflections that we might have. If your negative is in front of the function, it's going to reflect it across the x-axis. Basically, up becomes down, down becomes up. That's what's going to happen when you put a negative in front here. However, if you put a negative inside the formula, it's going to shift it reflect left, right across the y-axis here. So for this first one, since the negative's on the outside, it means that we are going to shift it down. So we go ahead and shift it down here. And that means it's still going to be at 2, 0, but instead of going up and to the right, it's going to go down. And something like this here. This is an open circle. And then on this other one here, we're shifting it left and right, but you gotta be careful because we're shifting it or reflecting it about the y-axis here. So instead of being over here at positive 2, it's going to be at negative 2. And again, it's the mirror image, so something along those lines. Okay, so you're reflecting it around one of the axes here. The last one is called stretching or compressing. I will give you my personal opinion that that is not super important, because the idea is this is though it stretches out left and right or up and down. The problem is if you look at your typical axes here, no one says that that has to be a 1. That could be a 2 or a 4, depending on what you want to count by. And so when you draw a parabola graph and you stretch it out, well, if you were to then change your counting by going over right by 2 every time, it might get back to the same parabola you started with. So the whole stretching and compressing, personally, it just comes down to the scale on your graph, what it's going to look like. And so you could have 2 graphs that were different formulas, but they gave you the exact same picture because you changed the scaling when you're actually drawing the graph. So regardless, if I want to actually do this here, I can go ahead and say, okay, f of 2x here, that means whatever your x value is, you double it before you find your y value. So since originally at 2 we got 0, if I plug in 1 into here, 2 times 1, that's where I'm going to get 0. So it's going to be, everything's going to be kind of compressed horizontally by a factor of 2. It's going to be only half as wide as it was originally. So again, I would worry more about shifting, up, down, left, right, and reflecting. Those are the more common things you need to worry about.